Hey guys, welcome back. So, I'm going to talk to you about solving inequalities on variables today. There's already a lot of stuff you should know because this skill was first introduced. Already had going on. They said they knew so those four signs are greater than, less than, greater than or equal to, less than or equal to. So they said, hey, we know the four signs. You're going to have to use a number line. And you're absolutely right. We can solve solutions to inequalities on a number line. Okay. Another thing they said was that you're going to solve them similar. And then with inequalities, there are going to be multiple solutions. So you're not just going to have one thing that works, but you'll have... Sorry for the weird coloring there, my pen went out. Alright, so we have our essential question. How are solutions of inequalities different than solutions of equations? Well, we already talked about that a little bit. We talked about how solutions to inequalities, so solutions to inequalities, and I'm going to say always have multiple solutions. While equations have usually one solution. Okay? So equations going on here. So your basics of inequalities are going to be what you need to know in order to solve for inequalities. So there are four signs. You have greater than, you have less than or equal to. So those are going to be your open dot solution. Your closed number and everything less than it. Okay? So we're going to solve inequalities very, very similarly to how we solve equations. We do what we do to one side of the, instead of equal sign, it's inequality sign, any of the four above. We must also do to the other side. So if we add, subtract, multiply, or divide, we do it on one side, we do it to the other. The goal is to have on one side of the inequality sign and the constant or the number on the other side. Okay? The following are special only to, oh wait, not yet. One solution, which means one stipulation. No solution. Infinitely many solutions. I'm going to spell this as many solutions. And I'm going to just put sol there. Infinitely many sols. Because I want it to ran out of room there. Okay? Now let's talk about what's special to just inequalities. When multiplying or dividing by negatives, you must flip the inequality sign. So if you multiply by a negative or a negative number, or since there are multiple solutions to inequalities, we can graph them on a number line. So we graph these on a number line. Alright, so now let's just jump right into solving them. Example 1 tells us to solve them and graph the solution. So the first thing I'm going to do is rewrite the equation. So we have a negative 4 times 3x minus 1 plus 6x less than or equal to 16. So what do we have to do first? Definitely see that there's a negative 4 next to a parentheses there. So we want to make sure to distribute. So we get negative 12x plus 4 plus 6x greater than or equal to 16. Okay. Awesome. Now what? Well, we are still trying to get all of our x's on one side and our numbers on the other. So our next step is combining our like terms. Plus 4 greater than or equal to. Okay. Now we solve it just like an equation where we're going to subtract 4 on both sides, leaving us with a negative 6x. At this point, we're going to divide by a negative 6. And we're going to get x is greater than or equal to. Oh, wait, no. We have to flip our sign because we multiplied by a negative. So flip our sign and we get negative 2. I'm going to write over here, flip sign b by negative. Very important. And then I'm going to highlight it because we have to see that we have to flip our sign. Okay? So graphing. So to graph, we have to make it with a number line. So here's my number line. I'm going to put my 0 in the middle. 1, 2, 3, negative 4. 1, 2. So we are going to have an equal to. It's going to be a closed dot. Then we want to pick a number. So if we plug negative 3. Negative 3 less than or equal to 2. Is negative 3 less than or equal to 2? It works. So we are going to shade our arrow this way. That's it. Number line. Pick one, try it out. If it works, shade it. If we would have chosen 0, then that would have told us it didn't work and we'd know to shade the other way. So good job there. Now, I'm not going to do everyone, but I am going to show you that we can check our work. So when we check, we just plug it in to see if it makes it true. So negative 4 times 3 times, we need to pick a number bigger than negative 2. Or less than negative 2, my bad. Less than negative 2. So let's choose negative 4. Minus 1 plus 6 times negative 4. So 8 greater than or equal to 16? Yes. Because this is true, we did it right. Yay! We can check our answer. So whatever you pick on the side that you do, it should be true. It should give you a true statement when you plug it in if you pick it on the side that you shaded. All right. So I want to show your learning problems, but I want you to understand that I'm not going to work them out for you. I want you to pause the video and I want you to try it yourself. See how it's going to work. So at this point, if you're watching this and you're showing this to you, pause your video, try it, see how it works. Now let me show you the answer so you can check your work. Again, you always have access to the answers in class, so you can always check these in our binder. Alrighty, let's keep going. Let's try another one. Solving an inequality with variables on both sides. Boom! So just like we had variables on both sides with equations, we also have variables on both sides with inequalities. So the first step of 3.5x plus 19 less than or equal to 1.5x minus 7. The goal with variables on both sides in equations is to get x on one side, numbers on the other. That goal has not changed. It's the same goal here. So first things first, let's go ahead and subtract our 3.5. Then we have 19 is greater than or equal to negative 2x minus 7. Okay, the next thing we need to do is get that 7 on the other side. So add 7. 19 plus 7 is going to give us a 26, so it's greater than or equal to negative 2x. So now what we're going to do is divide by negative 2. Alrighty. So what we're going to get is negative 13 greater, flip your sign, x. So we flipped our sign, so I'm going to color that little guy yellow so you know. So now all that's left to do is to create a number line. So I don't and go negative 4, negative 8, negative 12, negative 16, and then 4, 8. As long as you have some sort of scale, that'll work for me. Negative 13 is probably about right here, so go ahead and put your dot. We want numbers that are going to be where x is bigger. So notice, we don't always shade in the way it shoots, because that's not going to work. If I was to choose negative 16 is not bigger than 13, so we don't shade this way. We need to choose another number. So let's choose 8. Is 8 bigger than negative 13? Yes, it is. So we shade this direction. Alrighty. So that's all for that one. Usually I don't do the try your learning or show your learning with you, but we have not done a problem yet where we don't have to flip our sign. And in this case, we can solve this in a way where we don't have to flip. Remember, you only flip your multiplying or dividing by a negative. I want to show you one where you don't multiply or divide by a negative. So I rewrote the problem. I subtract by 2x, negative 5 less than 3x minus 22. Try to get my numbers on one side, add 22 to both sides. You get 17 less than 3x. We're going to divide by 3 on both sides. So we're going to get x is greater than 17 over 3. Or, if we break this into fraction mode, we're going to make this 5.7. You don't have to turn it into 5.7, but it's a lot easier to make it into that. Notice, there was no flipping of the signs because when you divide by a positive, you do not have to. So here's our number line. I'm going to put my 0 over here, my negative 2 here. 2, 4, 6, 8. We want to go to our 6. Notice it's a no equal to there, so it's an O, and we want numbers that are bigger, not 6, right at 6. So like right there, 5.7. Well, 6 is going to be bigger, so we're going to shade. And there's how your final graph looks. There you go. All right. So now let's briefly talk about infinitely many and no solutions when it comes to absolute value equation. So all we're going to do is we're going to solve it. So I'm going to rewrite the problem. So then we're going to distribute, sorry for hitting the camera there. We're going to get negative x plus 15. So notice, I'm going to stay still for a second just in case it took it a little time. We are going to distribute and get negative 6x plus 15. Now we have variables on both sides. So what we're going to do now, cancel, leaving me with 15 is greater than 9. Well, notice 15 is in fact greater than 9. So this is a true problem. Or you may see this as all real numbers. Either one works when writing them out. So this is an infinitely many solutions, or an all real numbers. If you are ever solving, your variables disappear, and you have a true statement, you have infinitely many solutions. Let's see what happens when the opposite occurs. Oh, and you don't have to create a number line for this, because on that number line, it would just have everything selected. Let's look at this one. Rewrite the problem, 4x minus 2 times 2x minus 3. What do we do first? Distribute. So we have 4x minus 5 less than 4x minus 6. Give you a second to see the distribution there. Now we're going to get our 4x's on the same side by subtracting 4x, subtracting 4x. Well, what happens? The 4x's cancel. We're left with negative 5 is less than negative 6. Well, is negative 5 less than negative 6? No, that's not right. This is a false statement. False statement, we have a no solution. So, if you are solving, your variables cancel, and you're left with a false solution, or a false statement, you've got a no solution. Okay. Not going to stay long on these, just want to point out one big key factor with A. You get 4 is less than 4. Is 4 less than 4? No, that's a false problem. The reason it's false is because 4 isn't less than 4. Now remember, with equations, if we got 4 equals 4, yeah, we did it. But it's not supposed to know if this is true, false, or how it works. Okay? Alright. Only a little bit left. So we've got applications of inequalities. So we got Skylar competing in a high jump event at her school. She hopes to break some records at the next meet. So she wants to break some records. Remember the state record, 1.75? Well, A says write and solve an equation X to see what she must do to tie the district record. So let's take a look. Personal best is 1.48. Plus some amount of meters she needs to add to it, and she wants to tie them. So tie would tell us to equal. The state record is 1.57. So that's our equation. To solve it, we just subtract negative 1.48 on each side, and we get m is equal to 0. Well, if we want to break the district record, we want to do 1.48 plus m, but this time we want to be bigger than 1.57. We're going to solve this the exact same way by subtracting 1.48 on each side, but this time our answer is going to be m is greater than 0.09. And finally, last but never least, well, what if she wants to break the state record? Well, then we're going to use the exact same formula for 8 plus m, but she wants to break that state record, so keep our greater than, and this time it's 1. Well, we're going to subtract 1.48 on each side, and we're going to get m to be greater than 0.27. So as you can see, there are a lot of fun and amazing ways that we can play with this. We can create things from inequalities. So let's solve a problem. We got a flower shop. Eric wants to order some roses online. For what number of roses is it less expensive to order from florist A or from florist B? So expensive from A and from B. Well, let's write out what we want. We want A to be less than B. So we're going to let X equal the number of roses. So our X stands for how many roses are we buying? Well, then here's our formula for A. So look at A. It's $4.75 per blue rose plus a $40 delivery charge. So it's $40 no matter what. plus 4.75x. Look at B. B is $5.15 per rose and a $25 delivery charge. So 25 plus 5.15x. Remember, we want A to be less than B. So we're going to do 40 plus 4.7 less than 25 plus 5.15x. Now we just need to get x on one side, number on the other. So let's subtract 4.75x on each side. And we get 40 less than 25 plus 0.4x. Then, side, that's going to give us 15. So if we divide by 0.7.5 is less than x. All right, so let's talk about this. Can we get 0.5 of a rose? I want 0.5 of a rose. Can that happen? No. So if Derek plans to buy more than 38 roses, then A is less expensive. But if he plans to buy less than 37 roses, and let's use the word in. What does the word inclusive mean? It means if he buys exactly 38 roses, A is less expensive. So it's 38 or less. If he buys, or 38 or more, my bad. If he plans to buy 38 or more roses, then A is less expensive. If he plans to buy less than 37, so 37 or less, then B is less expensive. Inclusive means include the number that you used. So 38 or more, pick A, it's less expensive. 37 or less, pick B, it's less expensive. All right. In the last couple of minutes, I am going to show you the reteach to build, or math, lit, and vocab. I really enjoy the math, lit, and vocab, but I'm not going to work it out and watch me draw horrible lines. I'm going to show you what we got. So, I wanted you to be able to match them. So if you have 3 less than a number n is greater than 9, then here's 3n minus 3 greater than 9. If you have t is greater than 42, then must be over 42 inches tall to ride does exactly make sense. If you have the length of the fish is under 3 feet, then f less than 3 absolutely makes sense. Here, it is possible to match the words that we make with the actual inequality. Okay, finally, let's look at some graphs. P is greater than 3. We know greater than has to have an open dot, and we need the numbers bigger than 3, so r and 4. So that tells us r over 4 is greater than 2. So you've got to solve for r by multiplying by 4 on both sides to get r is greater than 8. Then we see open dot at 8, pointing toward the bigger numbers. So, if you need to see more of these, want to understand more, you can pause the video to look at the answers. Otherwise, you guys have a great day. We've had a wonderful little review of 1-5, inequalities in one variable. If you need any help, let me know. Have a great day. Bye.